In other words, how they have to give up food for shelter. So what we're trying to bring in line is a consumer's willingness to give up with the rate at which they have to give up. And this, in basic terms, is making your benefits equal your costs, essentially. Okay, so if we look at point C now, we can determine that condition 1 is met. Point C is on the budget constraints, and so it is true that the consumer is spending with all their income. But condition 2 isn't being met at point C. What we can see is that at point C, the slope of the budget constraint is given by the steepness of that line, whereas the MRS, which is the steepness of the indifference curve, is like that, if I just imagine a tangent line to the indifference curve at point C. So it is clear that at C, the marginal rate of substitution is less than the relative price of shelter. So the marginal rate of substitution is less than PS over PF. That means that the marginal utility from shelter divided by the marginal utility from food is less than the price of shelter over the price of food. So I'm just replacing MRS with the marginal utilities. I'm then going to rearrange this slightly to put it in terms of Gosson's second law. So I'm going to swap where these two are positioned, and that's not going to change anything about the direction of this sign. So MUS over the price of S is less than the MUF over the price of F. So this is what we can use to determine how. So what must the consumer do? How should they change their consumption in order to bring them to an optimum point? So this tells me that the additional utility that they would get from consuming a little bit more shelter, whatever they had to spend on that shelter, is going to give them less extra utility than spending a little bit more on food. So this tells me that food currently offers them the cheaper satisfaction. They're able to achieve greater additional utility from spending more on food than from spending more on shelter. And so food in this instance is the product that they should be consuming more of. So if they're at C, their decision should be to reallocate their budget in such a way that they decrease the amount of shelter they consume and they increase the amount of food they consume. So they need to move up along their budget constraints. And they would continue to do so until they reach this point here, B, which is the optimum point for this consumer. Because at B, the marginal rate substitution is equal to the relative price of shelter. And that would then mean that they are meeting both of these conditions. So they are spending all their income, they're on the budget constraint, and they are equating their willingness to give up food for shelter with the rate at which they have to give up food for shelter. But this helps us explain how that change occurs. So in this answer, you would have to indicate why is it that you believe the consumer needs to move up the budget constraint? Why does the consumer need to reallocate some of their spending away from shelter towards food? Okay, so that's this question. The next question actually relates very closely to this exact analysis here. It asks us, suppose the consumer that consumes clothes and food operates where this is currently true. So you can see how this relates to the previous question. Is the consumer in equilibrium? If not, how can the consumer adjust to equilibrium? Explain your answer in detail. So if this is condition 2, then clearly the consumer is not in equilibrium because these are not equal. The slope of the indifference curve, in other words, their willingness to trade these two goods for each other, is not the same as the slope of the budget constraint, which is the rate at which they have to trade. So these are not in equilibrium, they are not equal. So this represents a point that is not optimal for the consumer. So how does this consumer adjust to equilibrium? Okay, so we're going to use the same sort of thinking as we did here. So if this is true, then it must also mean that MUF over price of F is greater than MUC over the price of C. So all I've done is I've switched where these two are. So the margin utility from food divided by the price of food is greater than the margin utility from clothing over the price of clothing. In other words, food currently offers greater additional utility for each additional rand or dollar, whatever monetary unit spent on it. That is greater than the additional utility that would have been obtained from spending a bit more on clothing. So food currently offers the cheaper utility. It makes more sense for this consumer to reallocate their spending away from clothing towards food. So this is how they need to go back to equilibrium. Again, they also need to make sure that they are spending all their income. So in this question, we're only dealing with the one condition. So this implies definitely there is not an equilibrium, because for equilibrium, these two things need to be equal. So when they reallocate their spending away from clothing towards food, until MUF over the MUC is equal to the price of F over the price of C, that needs to occur. But this could be true off of the budget constraints. I mean, this could be true if we took this line and shifted it out, and then we found a point of tangency with a lower indifference curve. So this alone doesn't guarantee equilibrium. This needs to be combined with spending all their income. Okay, but this is how the reallocation or the adjustment will occur. You have to reallocate away from clothing towards food. How this would look graphically is that would be like you being at a point like A, because at A, your budget constraint is not as steep as your indifference curve. Again, this is the slope of your budget constraints, but this at point A is the slope of your indifference curve. And so we can see that this represents a point where the MRS exceeds the relative price, which is how this is represented. These two marginal utilities, if we take MUF over MUC, that gives us the MRS. So that would be like us being here. And so we reallocate our spending by moving down our budget constraints. Okay, so this is quite a bit of theory, but it will help you when you have to do an application type question. I'm now going to go to theory that looks at the Hicksian decomposition. So we get given the following graph, not drawn to scale, that shows the equilibrium positions of Temba, who consumes two products, steak and bread. So he spends his money between kilograms of steak and loaves of bread. If Temba's initial equilibrium position indicates that he buys 5 loaves of bread, answer the questions below. Okay, so what this is telling us is that this is where he starts off at 5 loaves of bread, which means this over here, that point there, is his initial best affordable point. I'm going to call that A. Okay, so I'm just going to use that to help guide our analysis. So he starts off at A, consuming 5 loaves of bread and some amounts of steak. I'm just going to label it S1. The question now asks which products, so which single product saw a price change and how did it change? Okay, so if this is our original best affordable point, then we look at which budget constraint is tangent to the indifference curve at point A. And we find that this line here that I'm highlighting in green, that is our original budget constraint. So I'm going to call it B1. So that's the original budget constraint. which budget constraint now reflects a price change of only one product. So there are two other lines drawn in my graph. We have this one here, and we have this one here. Now, this budget constraint here, if I compare it to our original one, that kind of pivot would not occur if just one product's price is changing. This kind of pivot would occur if there are either multiple prices changing or there's a price and an income change at the same time. So that tells us that this budget constraint over here must be the new budget constraint under a different price of one of the products. So this must be the new budget constraint. So I'm going to label it B2. And this budget constraint shows us that the intercept on the y-axis is the same as the original budget constraint, but the x-intercept is different. So the x-intercept has increased. It's pivoted out along the x-axis. So that tells us that the product whose price has changed is bread. So bread has faced a price change, and the price change has been that the price has fallen. The price has decreased. And the reason I can say that is because this intercept here represents how much bread I could buy with all my income. And if the price of bread is lower, it means that amount goes up. So this pivot outwards represents a price fall of bread. The question then asks, what is the substitution effect of this price change? Okay, so the substitution effect represents how does the consumer's consumption change given the new relative prices, so the new relative price, but holding utility constant. Okay, so the substitution effect keeps the consumer on their original indifference curve, so on this I1. But what they're having to do is they're having to now change their consumption choice because the prices of these two products in relative terms have changed. At A, their margin rate of substitution was equal to the old relative price of bread. The relative price of bread is now changed, which means A no longer represents a position at which you are making your willingness to trade these two goods equal to the rate at which you have to trade these two goods. The relative attractiveness of these products have changed. When the price of bread goes down, it means that the marginal utility that you get from bread divided by this new price is now larger than it used to be. If the denominator has gotten smaller, then this overall gets bigger. So that implies that the utility you get from bread, if you choose to buy a little bit more bread, is more for the cost than it used to be. And so that makes bread more attractive. It makes it more attractive than steak, which now is relatively more expensive. Even though the price of steak hasn't gone up, it is now more expensive relative to bread. So whatever utility you could get from consuming an extra kilogram of steak, that utility is now relatively more expensive than it was, making steak less attractive than bread. So this consumer is going to substitute away from steak towards bread. And we can see this graphically as taking our new budget constraint, which represents our new prices that we face, and we move it parallel outwards, which just means we're keeping those relative prices intact, and we move it all the way back to our original indifference curve. So what we're saying is when we find that point of tangency between our old indifference curve and this relative price, so this hypothetical budget constraint that represents our new relative prices, when we find that point of tangency, we are seeing how does a consumer change their consumption whilst keeping their utility the same. And so that takes us to 9 loaves of bread. So this movement from 5 to 9, the movement from A to C, is the substitution effect. And we see that it is plus 4 loaves. So the substitution effect of this price change on bread is to increase my consumption by 4 loaves of bread. Okay, but then what is the income effect of this price change? So now that we've substituted to keep our utility the same, we realize that C is inside the new budget constraint. In other words, C isn't exhausting all the income. So the income effect is this parallel shift out. It's saying, okay, actually we have more purchasing power, and so we can consume more through this extra purchasing power, through this extra income. And that takes us up to this point here. I'm going to label it D. So the movement from C to D, moving from our original indifference curve to the new indifference curve on our new budget constraint, represents the income effect, the movement from C to D. And that means that it is the movement from 9 to 8 loaves of bread, so minus 1 loaves. That is the income effect of this price change on bread. I could have also represented my substitution and income effects for steak. So this would have been the substitution effect for steak. So the substitution effect for steak, I would imagine, is going to be negative. And the reason is because if bread is now relatively more attractive to the consumer because its utility is now cheaper, then we would substitute towards bread away from steak. So there's the negative substitution effect. The income effect is the movement from C to D. So the income effect for steak is this positive change there. So this is the income effect. And so the income effect here is very large and positive. And so overall, it makes the total effect positive because this positive income effect dominates the negative substitution effect. In the case of bread, our total effect is positive. So the total effect is from 5 to 8, from A to D. So the total effect is 3 loaves extra. The substitution effect, we said, was to increase our consumption by 4 loaves, and the income effect was to decrease consumption by 1 loaf. And so we can see that the total effect, which is plus 3, is the substitution effect of plus 4. Sorry, I haven't been showing you this, minus the income effect of 1. And that's where we end up with plus 3 loaves. Is the product whose price changed a normal product or an inferior product? Briefly motivate your answer. So now we need to think about, how does the income effect look in response to the purchasing power change? So what is the direction of the income effect in response to a change in real purchasing power? So in this example, we see that real purchasing power is increased. If this area underneath the original budget constraint represents the feasible set, and we can say that the feasible set, the size of it, what is possible for us, represents our purchasing power. It's basically showing us what are all the different options we could choose from to consume. That feasible set has expanded because of this pivot of the budget constraint. So now there are a lot more possibilities available to me. That is the same as saying that my real purchasing power is increased. So in this example, real purchasing power has gone up. And so if we have greater real purchasing power, it means that we will consume fewer inferior goods and more normal goods. So inferior goods are defined as those that we consume less of when we have greater income, greater purchasing power. And normal goods are something we consume more of if we have greater income, greater purchasing power. So when we go back to the income effect, we see it is negative, and that's a negative income effect combined with a increased real purchasing power, which tells me that bread, that's the product whose price changed, is an inferior good. And the motivation would be to say that the income effect is negative. This consumer chooses to consume less with a higher real purchasing power. And that gives this good an inferior quality for this consumer. It doesn't mean bread is always inferior. It just means that for this consumer, under these conditions, bread is considered as inferior. Okay, so what I'm going to do now is I'm going to draw an example of the Hicksian decomposition. I'm going to use these two products that we used here. But in order to make the question different from the previous one, I'm going to switch the axes that they are on. And I'm still going to say that bread is inferior and that steak is normal. And we're going to see what happens if the price of steak, actually, let's make it increases. What happens if the price of steak increases? So here is the original budget constraint, and we'll say that the consumer begins off by consuming down here, so they're on the highest attainable indifference curve that they can reach given their current budget and the prices that they face. And so they consume so much steak and so much bread in initial equilibrium. So that is their initial best affordable bundle. Now we say the price of steak increases. That's going to result in the budget constraint pivoting inwards along the axis for steak. So let's say the new budget constraint looks like this. So that represents an inward pivot of the budget constraint because the price of steak has increased. How are we going to show this consumer moving to their new best affordable point? So I'm not going to jump straight to the price effect, so straight to that total effect. I'm going to break this down step by step because I want to show you the mechanics of the substitution and the income effect, and also show you how your graph needs to reflect the inferior and normal nature of these two goods. So I'm going to pause for a second and I'm going to reason through the substitution effect and the income effect of these two products, and then what I then would propose the total effect should end up looking like. So we have bread and we have steak. The first thing that we need to look at is how does this price change result in a change in consumption through substitution, holding utility constant. So the substitution effect would tell us that essentially bread now becomes relatively cheaper because steak has become more expensive. And so whatever additional utility I could get from consuming bread would now be cheaper than the extra utility I could get from consuming a little bit more steak. When we were at A, we knew that our marginal utility from steak over the marginal utility from bread equals the price of steak over the price of bread. So I'm putting this in this order because you always put the X variable in the numerator and the Y variable in the denominator. So what I'm saying here is that the rate at which I'm willing to trade bread for steak began off as equal to the rate at which I must trade steak for bread. Okay, so these two things are equal, which also means MUS over the price of S is equal to the MUB over the price of B. So if I just switch where these two things lie in that equality. But now the price of steak has gone up, so this denominator has become larger in value, which means this value here, MUS over the price of S, has gotten smaller. And so the marginal utility of bread per rand spent on bread now exceeds the marginal utility of steak per rand spent on steak. And so that is why bread becomes relatively more attractive to this consumer, because the extra utility they could get when they buy a bit more bread, that utility per rand spent exceeds the extra utility they could get from spending a little bit more on steak. So because bread is now the relatively more attractive product, we expect the substitution effect to be positive for bread and negative for steak. We can confirm this by showing that under our new prices represented by the slope of the new indifference curve B2, if I push that outwards until it meets my original indifference curve, and I draw in this hypothetical income change. So this is saying if we could have stayed as happy as we were before, so if I could have hypothetically received enough income to take me back up to my original utility. So were I able to stay as happy as I was before, how would I have changed my consumption of bread and steak so that I could achieve MUS over MUB now being equal to the new price of steak over the price of bread? So that movement from A to C is that substitution effect. It's holding utility constants, but it is changing the consumption of bread and steak so as to make the willingness to trade equal to the rate at which the consumer has to trade. So this is the substitution effect for steak, which is negative. And this is the substitution effect for bread, which is positive. So the graph agrees with my reasoning. Now I need to reason through the income effect. So the income effect tells us, how does the consumer's consumption of bread and steak change now that they have a change in their real purchasing power? So how does their real purchasing power now affect their consumption choice? So if we look at point C, it lies outside the feasible set of this consumer. This is now what is feasible below this line. So C is no longer feasible. So we actually can't be as satisfied as we were previously, because the higher price of steak has meant that we are now poorer in relative terms. And so the income effect would tell us that we face lower real purchasing power. And just like the previous example, if real purchasing power goes down, I buy fewer normal goods and more inferior goods. So the income effect for bread would be positive and the income effect for steak would be negative. That means I should expect to have a positive overall total effect for bread and a negative overall total effect for steak. So the income effects, using the reasoning we've just used, need to be in this direction for the two products. So wherever I draw my new best affordable bundle, so wherever I draw that final movement to my new best choice, has to reflect a positive income effect for bread and a negative income effect for steak. What that means is that I can't just draw my new best affordable point down there, because that would contradict what I've just said. If I drew my new best affordable point here, it would make the income effect for bread negative, which is not theoretically correct. It would make the effect for steak negative, which is correct. But it would completely contradict that bread is inferior. So I need to make sure that wherever I draw my new best affordable point on my new budget constraints has to reflect a positive income effect. So if the movement from C to D is my income effect, that's like me facing this lower real purchasing power. It's like I'm losing income. Then this movement from C to D is now positive, which completely confirms what we believe to be true using the theory of an inferior good in response to purchasing power. For steak, it is negative. And that again agrees with what we reasoned. So the new best affordable point of this consumer has to be somewhere that agrees with the logic of how a consumer responds by consuming different amounts of inferior normal goods when faced with different levels of purchasing power. Okay, and then we can now see that the overall effect for the bread consumption of this consumer is positive, which agrees, and the overall total effect for steak is negative, which agrees with this. So drawing out this graph needs to take into account these changes, and it helps to first reason through them before executing them on the graph, because otherwise you could end up with a D, so with this new best affordable point, that is in no way supporting what we know about a product. Okay, so now I'm going to do one more mathematical type question using a question that was on last year's A1, just so that you can get yet a little bit more experience in working with the solution when we aren't using a graph, but we're using a utility function, and then we have enough information in order to get our budget constraints. So the question tells us that Arnold consumes two goods, X and Y. His income is $360 per week, and his utility function is given by this function here. This represents a non-linear utility function, but also a utility function that would be asymptotic to the axes, because if I put 0 in for X, that would be 0, and if I put in 0 for Y, that would be 0. So this tells me that this utility function represents smooth, convex, indifference curves for ordinary goods. These aren't perfect substitutes or perfect complements in any way. The price of good X is Rand 6 and the price of good Y is Rand 16. So now we have all the information we need to solve for how much of good X does Arnold consume at his best affordable point, and how much of good Y does he consume at his best affordable point. Now these two have been broken up into two separate questions, but you can actually solve for them all at once. So I always go straight for this method because it makes the most sense intuitively. Always remember that there are two conditions for reaching a best affordable bundle. It is that you spend all your income. In other words, you are on the budget constraints, and you find a point of tangency where the marginal utility of X over the marginal utility of Y is equal to the price of X over the price of Y. So these two conditions have to be satisfied. I always start off with this, and then I use what I get here to sub into my budget constraint. So I'm using both of these conditions in solving for the best affordable bundle. So how do I get the MUX and the MUY? So the marginal utility of X is going to be the partial derivative of my utility function with respect to X. So when I take a partial derivative of this with respect to X, I treat Y as a constant. So this is going to be 3Y. If I then take the partial derivative of my utility function with respect to Y, same thing, now my X becomes a constant, and so it's going to be 3X. So now I have MUX is 3Y and MUY is 3X. I have both my prices, my PX is 6 and my PY is 18. So I can now say that in equilibrium, MUX over MUY must be this. And so 3Y over 3X must be equal to 6 over 18. These two cancel out. So what I have is Y over X is equal to a third. And so if I rearrange this, I could either get that 3Y is equal to X or Y is equal to a third X. So either of those two I could use as a substitution into my budget constraints. So now I start with my next condition. So my budget constraint is 360 is equal to the price of X times X plus the price of Y times Y. So this is me writing out M is equal to PXX plus PYY. I'm going to use this one because it looks slightly simpler. So 360 is equal to 6 times 3y. So I'm subbing in 3y for X plus 18y. So what I have is 360 is equal to 18y plus 18y, which is 36y. And that means that y is 10. If I divide both sides by 36, I get 10 equals y. So now I have my y in the best affordable bundle. So my X, I'm going to sub y equals 10 into here. And so 3 times 10 would give me X of 30. So this is my best affordable bundle. Now, something that I think is just always good practice to make sure that these are correct is substitute these back into your budget constraints. Okay, so what we need to check is it true that these end up using all your income? Because if these values you get here end up either being below or over 360 in total spending, that would imply that you've done something wrong and then you need to go back. Okay, so let's see. 360 is equal to 6 times 30. So I'm subbing in 30 for X plus 18 times 10. 6 times 30 is 180. 180 times 10 is 180. All good. So I can now trust my answer.